So another video for the surface geometry topic, and this time it's for transition pieces from circular to rectilinear. So here's an example of the question it's given to pupils. So you could be given a question like this of a circle, rectangle that's going into a circle. So first thing that the pupils need to do first, is divide the circle up into 16 parts, or whatever number of parts I would like to do. Then if we turn on the construction lines, so then we join, so using a quarter of the circle to each point, we can create 5 triangles. So from point A then to 5, point A to 4, point A to 3, etc. all the way to 1, and then when it gets to 1 then it also joins back to D, and vice versa up to 13 and 9. So you can create as many triangles as you want for each corner, depending on how many divisions you divide the circle into. So then if we transfer the points up into plan, up to top surface in plan, we can also create these triangles in plan as well. So then going back to one of the previous videos then of the transition pieces, this triangulation, again we need to find the true lengths of the points again, we need to find true lengths. So if we turn on this construction there then, so we bring across our heights there, and we rotate our points down. So because it's symmetrical, we don't need to find true lengths of every single division. We can find the true lengths of the quarter of the shape and transfer these then to apply to all shapes. So we start off as first, and we rotate our points down from point A all the way up to this horizontal, and then we bring them up vertically until they hit the XY line, up until they hit this top point. Then when we have these points found in plan, because this is point A and this represents point A here in elevation, if we turn on our construction line there, then we can find these true lengths. What we're essentially after doing is we're after finding the true length of 1 to point A, 2 to point A, 3 to point A, 0.5 to point A, etc. So then this gives the true length. So this means that we can start to develop, complete the development of the shape. So then the pupils can, this file will be made available to pupils, and that they can see where these points are coming from, where they're generated. They can turn off layers, see what points have come from where. Then it's coming over to this development then. So if we turn on our text layer then, so this is going to give us these points, so it's just going to represent the points here. And if we turn on then our construction lines, and then our type A lines here. Okay, so what we're bringing, and our render plane. So then, so then we could show this development here then to the pupils, and then we could turn off certain points of this. Not that line. Not clicking wrong thing here. So then we can show how these triangulations. So point A here, and then the 1, 2, 3, 4, 5. And these are true lengths then that we step off the plan. So if we can get a dimension to there, so let's say 4, 5, 5. So we can hover back here and show that these lines are the same. Then we can step in our point A4 line, point A4, point A2, and we can show that how these points are created. So like the divisions between say point 1 and 2 are the same as the divisions between the chords here. Sorry, get rid of this dimension. Between division here between 1 and 2 here, stepped off. So then this can show the pupils where these points are coming from. So we know the rectangles of this length. So if we turn back on our dimension tool again here, so we know that this length is 120. We also know the length of this rectangle down here is 120 as well. So then, because we know these are true lengths because they're parallel horizontal length, and then this allows us to step off these points when we find them using this triangulation method.